Hi everyone, welcome to Brainy Elements. Last video, we have discussed, this topic we are discussing quantification of elements and its compound. In that, I said you there are how many subtopics? We have relative atomic mass and we have relative molecular mass, and then what's there? Relative atomic mass, relative molecular mass, and initially we discussed this atomic mass unit, relative atomic mass, relative molecular mass, Avogadro constant, Avogadro constant, then the mole, and molar mass. Last video, we have discussed atomic mass unit, RAM and RMM. Okay. Today, we are going to discuss the Avogadro constant. In this video, we are going to discuss Avogadro constant. And what is this Avogadro constant? Avogadro constant. Now, for example, you see the definition of Avogadro constant. When a mass of any element, when a mass of any element equal to its relative atomic mass is taken in grams, it is seen that it contains same number of atoms irrespective of the element. You see the key terms here. When a mass of any element is equal to its relative atomic mass, when a mass of any element equal to its relative atomic mass is taken in grams. In grams, remember, in grams, it is seen that it contains same number of atoms irrespective of the element. It contains same number of atoms. Same number of atoms. And the next key term is irrespective of the element. It can be for any element, irrespective of the element. Okay, now we'll see word by word. Now, let me take the carbon. Let me take carbon. What is the relative atomic mass of carbon? It's in the textbook. It's in the textbook. You see the relative atomic mass of carbon is 12 gram. Likewise, relative atomic mass of hydrogen is 1 gram. How to find this relative atomic mass? What is this relative atomic mass is given in detail in the previous video. Before watching this video, watch the previous video. After that, come to this video. I will put the link in the description. Carbon 12 gram, hydrogen 1 gram, and chlorine, I am writing the relative atomic mass. This is the elements. This is the elements and the respective relative atomic mass of the atom of the element. Okay. Chlorine 35.5 grams. Let me take like this. Now, the relative atomic mass of carbon is 12 gram. Now, I have a sample of carbon. Okay, this is a carbon. Okay, I'm going to take a sample of this carbon and then I'm going to place it on a scale. Okay, here I have a scale. Here it shows the reading. It shows the reading. Here I have a carbon piece. Here I have carbon. I'm going to take this carbon and then there is a pan over here. In this pan is kept on top of the balance. It can be the now chemical balance or any type of the measuring instrument to measure masses. Okay, that's a pen. I'm going to take the carbon. I'm going to take a mass of carbon. What is the mass? I'm going to take mass of any element, mass of this carbon atom. In this example, I'm going to take the mass of carbon atom. I'm going to take mass of carbon atom that is equal to relative atomic mass of carbon. I am giving the explanation for this with respect as taking the carbon as the example. I'm going to take a sample of carbon. What is the mass of that carbon? I'm going to weight it. What is the mass of that carbon? The mass of that carbon is equal to relative atomic mass of carbon. What is the relative atomic mass of carbon? 12 grams. So I'm going to weight this now. I'm going to take what should be the reading here? When I measure the reading should be 12 grams. Now I have taken a sample of carbon. Okay, what is its mass? 12 grams. Okay, in grams, I have taken in grams, 12 grams. There will be certain number of atoms. No? Now I have taken a sample of carbon. This carbon will have many number of atoms. It will have a certain number of atoms. I have taken now this carbon is made up of so many number of carbon atoms. No? So in this 12 grams of carbon, there will be many number of carbon atoms. And then there will be a certain number of carbon atoms. No? Yeah, same number of atoms irrespective of the element. Now, this is the point that you should understand. It will have a certain number of carbon. Let me take, there will be X number of carbon. Now, for example, let me take, there will be, I'm taking as an example, okay. There will be a certain number of carbon. Let me take X number of carbons. I don't know the value. There will be X number of carbons. Now, what am I going to do? I'm going to take this now chlorine. Like the other case, I'm going to take a chlorine and then I'm going to take a sample of chlorine. I'm going to measure the mass of chlorine that is equal to the relative atomic mass of chlorine. I'm going to take chlorine. I'm going to take some part of this chlorine. I'm going to weight the chlorine on a chemical balance. I'm going to read the reading that is shown by this chemical balance. And now what does this chemical now what is the mass that I'm going to take? That is equal to relative atomic mass of that element. So now what am I going to take? I'm going to take 35.5 grams of chlorine. 35.5 grams of chlorine. This is chlorine. This is chlorine. And this is also chlorine. I'm going to take, what's the mass? 35.5 grams of chlorine. Okay. Now there will be a certain number of atoms. There will be a certain number of atoms. And what is the number of chlorine atoms present? That is also X number of chlorine atoms. X number of chlorine atoms. Now likewise, I'm going to take hydrogen. I'm going to take some sample from this hydrogen. I'm going to weight the hydrogen. What should be the reading in this chemical balance? Reading in the chemical balance should be 1 gram because I'm going to take the mass of the element that is equal to relative atomic mass now. It should be 1 gram. I'm going to measure 1 gram of hydrogen. Then there will be a certain number of atoms now. What will be the number of atoms? That is also will be X number of hydrogen atoms will be there. So now you see the definition. When you take something equal to relative atomic mass in grams, the number of atoms is equal to a certain value. Number of atoms is equal to certain value. I will tell you what is that value, irrespective of the type of element. Now for carbon also, if I take equal to relative atomic mass, there will be a certain number. For hydrogen, if I take relative atomic mass, there will be a certain number that is X, certain same value that is to the carbon. If I take chlorine, if I take 35.5 grams, there will be a certain number of chlorine atom. there is a certain value. I'm going to tell that value. Okay. Therefore, there will be same number of atoms. There will be same number of atoms irrespective of the element. It can be any element. It can be any element. There will be same number of atoms. That number of atoms. Now I said you there will be a certain number of atoms. No, I said you there will be X number. No, what is that value? They have calculated. Scientists have calculated it. What is that X? What is that X? X is equal to 6.022 into 10 to the power 23 times. But they have calculated the value that is equal to 6.022 into 10 to the power 23. Okay. This value is known as Avogadro constant. You see, Avogadro constant. Why is that constant? That is a constant value for any element if I take the mass of that element equal to its relative atomic mass. Okay, that's it. This is what is known as the Avogadro constant. This value is known as Avogadro constant. So, if I take 12 grams of carbon, what is the number of atoms? That is Avogadro constant. What is Avogadro constant? That is 6.022 into 10 to the power 23. If I take 1 gram of hydrogen, there will be how many hydrogen atoms? 6.022 into 10 to the power 23. If I take 35.5 grams of chlorine, there will be how many atoms? Chlorine atoms. 6.022 into 10 to the power 23. Okay. Now I said you for atoms, no, I said you this example for these atoms. This is the same concept for molecule. You know what is atom, what is element, what is molecule, what is compound in the previous video, discussed in the previous video. So this is for atoms. I have given this example for atoms. This is for atoms. Now let's see for molecules. The same concept, only the terms get differ. Here atoms mean they are molecules. They are molecules mean here atoms. Only the terms refers, but the concept is same. The concept is same for atoms and molecules. Now we'll see what is the Avogadro constant under molecules. See the definition. When a mass of any substance equal to its relative molecular mass, I will put RMN, okay, that is relative molecular mass. You cannot write like that. You should write the full term in the examination. Relative molecular mass is taken in grams. Taken grams. It contains same number of molecules. Same number of molecules. The same number. Irrespective of the type of molecule. Now, for example, let me take CO2. CO2 means carbon dioxide. CO2. Let me take CO2. What is the relative molecular mass of CO2? You know how to find the relative molecular mass of CO2. There are two ways. One way is with that equation. Other way is they should give the relative atomic mass of carbon and the oxygen. From that, you can calculate the relative molecular mass of carbon dioxide, that is CO2. Then SO2, then Cl2. What is the relative molecular mass of CO2? That is 44 grams. Relative molecular mass of SO2 is 64 grams. Relative molecular mass of Cl2 is 71 grams. Okay. So I'm going to do the same experiment which I did for atoms. I'm going to take a sample of here. There is CO2. From this CO2, I'm going to take a certain mass. I'm going to keep it on a balance, and then I'm going to see the reading. Here, what is the mass that I'm going to take? The mass that I'm going to take is equal to the relative molecular mass of that CO2. I'm going to take a mass of CO2 that is equal to relative molecular mass of CO2. Now, when I take a sample that is equal to relative molecular mass of CO2, that is 44 grams. I'm going to take 44 grams of CO2. So, in grams, there will be a certain number of atoms now. Let me take there are Y number of CO2 molecules. Not the atom, here its molecule, Y number of CO2 molecules. Likewise, I'm going to take a SO2 sample. Here I'm going to take SO2. I'm going to take a certain mass of SO2. What is the mass of SO2? That is equal to 64 grams. That is equal to 64 grams of SO2. And this SO2 will have certain number of atoms now. What is the number of atoms? It is the same Y number of molecules, sorry, not the atoms. Y number of SO2 molecule. Likewise, if I take Cl2, I'm going to take Cl2. I'm going to take a mass of Cl2. Cl2, what is the mass of Cl2 that I'm going to take? That is equal to its relative molecular mass. I'm going to take 71 grams of Cl2. There will be certain number of molecule, Cl2 molecule in this 71 grams. And what is the number of molecule? That is also Y number of Cl2 molecules. So this should have a value now. What is that value? It is the same value for atoms. That Y is equal to 6.022 into 10 to the power 23. So if I take 44 grams of CO2, what is the number of CO2 molecule? That is 6.022 into 10 to the power 23. What is it? That is the Avogadro constant. Avogadro constant. Avogadro constant. If I take 64 grams of SO2, how many number of SO2 molecule? Avogadro constant. If I take 71 grams of Cl2, how many number of Cl2 molecules? That is Avogadro constant. I hope you must have got a good understanding in this. Okay, that's it for this video. If you understood it, give your comments in the comment section below. Okay, that's for this video. Let's meet on the next video. Please like, share, subscribe to Brainy Elements. Thank you.